Okay, now I'm going to try to do a video that gets at least to problem number 12. Just going to kind of watch the time and keep them relatively short. Okay. All right, so let's go ahead and get started. Here's where we're starting to actually just find derivatives of things. Okay, so on problem number 5, you have 4x to the third minus 6x squared plus 4e to the x. So it's just adding and subtracting of things. It says to find the second derivative. So you'll start by finding the first derivative. So the first term is just a power function. So you can just do 12x to the second. You bring down the exponent and then take 1 away. So you do 3 times the 4 and then x to the second. And then this would be minus 12x using the power rule again. And then here, be careful because you're not going to bring the x down. You're not going to be using a power rule. The derivative of e to the x is e to the x, and the constant just gets brought down along with it. Constant multiple rule says you can do that. And then you've got to do y double prime. So that means you have to go again. So this becomes 24x minus 12, but then also the 4e to the x. And they just wanted the second derivative. We're not trying to do anything else, so that's going to be your answer on that one. Okay. All right, let's take a look at number 6. All right, on that one, we're doing the derivative, but it gives us a hint there. It says by first expanding or simplifying the expression. So with number 6, you have f of x equaling 5x squared plus 30x, all divided by 5x. So it looks like it might be a quotient rule problem, and it would work if you did the quotient rule, but really you should just take a moment to simplify that. See, that's a single term down there, so it can be distributed into both of the others. You could knock out 5x from both of those. So you'd have an x left in the first spot and a 6 left in the second. So f prime of x would just be 1. Okay. All right, and I knew that just because that was a line. So I know the slope of the line is 1, so I know the derivative would be 1. Okay. All right, now you could have used the quotient rule, but that would have been a whole lot lengthier. Right now on 7, we have what appears to be a polynomial. But then on this one, they're giving us a value, and they want us to get equation of the line tangent. So we want the line tangent at at x equals a. All right, so you should think about that. Your plan should be to get the derivative formula, get the value of that at a equal 2, and then write the equation of the line. Okay, so let's go ahead and do the first derivative. We're just using power rule over and over. Okay, so that's the first derivative. Then I need to find out, well, what's the value of that at 2? So I'm going to plug in the 2. And that's going to be 3 times 4, which is 12, minus 4, which is 8. Okay, that 8 right there represents the slope of the tangent line at an x value of 2. Okay, so now I'm ready, almost ready, to use this formula and plug in. Problem on this one was they gave me only the x was a, so I know that x is 2. So if I need the y, I'm going to have to plug 2 into the original formula. Okay, so into the original formula. Okay, I'm not trying to get the value of the derivative at 2 right now. I'm trying to get the value of the y coordinate when x is 2. So I do that, and that's 8 minus 5. Turns out to be a negative 5 for the y coordinate. Okay. All right, so that just means that I've got the point is negative. The point is 2, negative 5. And the m I found earlier was over here, was 8. So I'm going to take those two pieces and plug them in. So this would become y minus a negative 5, which is y plus 5, and then 8 times the quantity x minus 2. So you'll distribute, okay, and get 8x minus 16. Then you'll subtract 5 from both sides and get 8x minus 21. And they wanted you to go to that point to get the equation of the line tangent. So that would be your answer on that one. Okay. Let's keep moving. On number 8, I'm just asked to do the derivative. Okay. So you can use the quotient rule on that, or you can make it a product rule problem in a way by doing that, but then you'd also have to make sure that you do the derivative of the inside of this. I think when we were doing it in class, most of us felt like it was just easier to go ahead and use the quotient rule. So that's the one where you do the low d high minus the high d low over the low squared. Okay, so the low times the derivative of the high, which is a power function, minus the function on top times the derivative of the low, which is 1, over the low squared. Now here you can sometimes do some factoring when necessary. This one I think is just as easy. Oh, and that right there should be y prime. Okay, but this one is probably just as easy to go ahead and distribute. Here that would be minus x to the third. You don't normally multiply out. You typically want things in factored form. So 3x to the third minus x to the third would be 2x to the third minus 3x squared, all of that over the x minus 1 quantity squared. And that's all they wanted on 8. Okay, so that's an example of the quotient rule. All right, now 9 is asking us to get the equation of the tangent line at 1, 2. So we want the tangent line at the point 112 actually, and the function we're dealing with is this. Okay, so your plan should be to get y prime and then to wind up to, this must be an x, to get y prime and then to wind up evaluating it at x equal 1 and then to wind up writing the equation. So y prime first, it's a quotient rule. So low times the derivative of the high minus the high times the derivative of the low. Let me put the derivatives in brackets. All of that over the low squared. Okay. So see how that's going to be gone. This will be minus 72x over the x squared plus 2 squared. Okay. All right, now this problem didn't just ask for y prime. It said to get y prime, and then it says find the equation of the line tangent to the original curve at x equal 1. So what we need now is what is the value of y prime at 1? So we're going to take, let me do it down here instead. So to find y prime at 1, we're just going to put a 1 in where the x is. So that'll be negative 72. This would be 3 squared. And negative 72 over 9 is a negative 8. So that's the value of the derivative at x equal 1. So that's your slope that we're going to use. And then they did give us the point already, so we don't have to find the 12. We were already given that. The 12 came from putting a 1 in right here in the original function. Then you get 36 divided by 3, and that's where the 12 came from. But we didn't have to find it in that case. So now we just go and set things up. Y minus 12 equals negative 8, x minus 1 is negative 8x plus 8. And when you add 12 to both sides, it's negative 8x plus 20. And they wanted that. That was number 9. Get the equation of the line tangent to the original curve at an x of 1. Okay. All right, let's take a look at number 10. All right, that one, 10 and 11, they're just finding derivatives. Let me just write them next to one another. Just get the derivative, it said. All right, that's a t. All right, so I got both of those written correctly. So this one is a product rule, number 10. This one has a product rule component, and then you can use the power rule. Okay, so on that, you can do 1d2 minus 2d1. All right, so let's separate it there. So let's take the first function times the derivative of the second, but don't forget to do the derivative of the inside. So that's actually times a -1. So this is the derivative of the second part. And then it's not minus, it's plus, sorry. And then plus the second one, which is e to the -x, times the derivative of the first, which is 4x. Okay. And then you just have to try to write that as concisely and neatly as possible. All right, so I don't know. There's a couple things I might do. I might just go ahead and put the -1 times the 2x squared with the e to the -x. Then here we have plus 4x e to the -x. So let's see, I could factor out an x. I could factor out a 2 and an e to the -x. Okay, so I could factor out a 2, an x, and e to the -x. If I did, I'd have a negative x, okay, then plus 2. Okay. All right, so this right here was where I started the y prime. All right, and then I might just rearrange that since it's got the negative there. I might write it as 2 minus x, or I might have factored out a negative along with the 2 to have it look just a little different. But it's really okay either way. Okay. All right, so I would probably go this far. Okay. All right. And you could have written the e to the -x in the denominator as e to the x as well. So, or could have done the 2x with the 2 minus x, and then down here an e to the x. That's also okay. All right. All right, so let's come over here to number 11. We're going to have to use the product rule on this part. So we'll do, when we start to do the derivative, we're going to take that and use the product rule. So we'll do the first function times the derivative of the second. Okay, and then we're going to do plus the second function times the derivative of the first. And then we're going to do the derivative of the square root of t, which is really t to the 1/2. So it'll be minus 1/2 t to the -1/2. Okay. All right, now, at that point, you can maybe do a little bit. Might take care of that and put the radical back in. It's not a lot that I could do. Even if I factor out, it doesn't really help that much. So I'm just going to leave this here. And then this, I might write it with the 5t to the 4th first, and then the tangent t. And then here, this is really 1/2 square root of t. Okay. All right. And see, since the t to the 5th, here I had a t to the 4th. Since I can't really factor out a good t from everything, I might just leave it the way it is. And on 11, our job was just to get the derivative. So that's good enough right there. Okay. All right, let's see. Number 12, let me squeeze that in right here. Number 12 actually wants me to find the second derivative, and I'm starting with y equals 2x cosine, nope, 2x sine x. Okay. All right, so I'm going to do second derivative, but I'm going to do the first derivative first. So I'm going to do first function times the derivative of the second. plus second function times the derivative of the first. Okay, you can take a moment to kind of organize it. Might want the 2 to be in front of the sine x. Then get ready to do y prime. So now I'm going to use the product rule again. So I'm going to do the first function times the derivative of the second, which is negative sine x, plus second function. So I'm still working on this. Second function times the derivative of the first. And then I've got to go and do the derivative of 2 sine x. The 2 is a constant multiple out in front, and the derivative of sine is cosine. Right? So I have a negative 2x sine x, and then here I have plus 2 cosine x, and then another plus 2 cosine x. So don't forget that all of this right here is the result of doing the product rule on this one. Okay. All right, so we can do a little more consolidating because these could go together. 2 cosine x's plus 2 cosine x's would be 4 of them. And that would be your final answer. So that is number 12. And let me go ahead and squeeze number 13 in. And then we have a bunch of problems that deal with the chain rule coming up. All right, so here's 13. 13 asks, does this function right here have any horizontal tangents? Okay, and so you should think horizontal tangents would have an m equal to 0. Okay, and we want to do that on the interval from 0 to 2 pi, including the ends. Okay, so that's kind of my thought process. Horizontal, ooh, don't know what happened there. Just a second, let me bring that back up. Okay, get it down to 100. Okay, so horizontal tangents, slope is 0. Got to figure out where that happens between 0 and 2 pi, including the ends. I've got my y, I need my y prime. So the derivative of tangent is secant squared. Okay, the derivative of negative x is negative 1. So I want to find out where does that equal 0. And so you got options, but I'm a factorer, so I like to factor that. Secant x, minus 1 plus 1. When you FOIL that back out, you'd get secant squared x minus 1. And then for two things to multiply to be 0, either one of them has to be 0 or the other one would have to be 0. So either secant x equals 1 or it equals negative 1. And then secants, you could think about it in terms of a secant. It's just easier to think of it as 1 over cosine. Okay. And so if I multiplied both sides by cosine, I'd have that the cosine of x, so it would be here and here. So it would look backwards, but I'd have that cosine x could be 1. And then over here, if I did the same type of thing, I'd have 1 equals negative cosine x, but when I divide by the negative 1, I'd get that cosine x equals negative 1. You also could just say to yourself, cosine is the reciprocal of secant, and the reciprocal of 1 is 1. You could do the reciprocal of both sides. So the reciprocal of secant is cosine, the reciprocal of negative 1 is still negative 1. All right, so now is when you go to the unit circle and you think about how cosine is really the x coordinate as you go around that unit circle. And then we're back to 2 pi. So for cosine to be 1, we need to be there. So that would be when x equals 0 and 2 pi. And then for cosine to be negative 1, you need to be over here. And so that would mean x would have to be, now I'm not trying to say negative pi, that's just pi. To be negative 1, you'd have to be over here. So that would be x equals pi. So your answer to the question would be 0, pi, and 2 pi. Okay. And yeah, does it have any horizontal asymptotes? Yes, it does. It has horizontal asymptotes at an x of 0, at pi, and at 2 pi. Okay. All right, so let me get this one posted.